Today we're going to be focusing on quotient properties with higher roots. These things work exactly the same as they did with square roots. So here we have a problem, the cube root of a to the 8th over a to the 5th. And in this case, it's helpful to simplify the stuff inside. A to the 8th over a to the 5th simplifies down to a cubed. So this problem becomes the cube root of a cubed. And by the Orndorff rule, 3 goes into 3 once, so it would simply be a to the 1st. If we look at the next problem, we have the 4th root of a to the 10th over a squared. Again, this one's nice because it'll simplify inside. A to the 10th over a squared is a to the 8th. And the 4th root of that, by the Orndorff rule, would just be a squared. 4 goes into 8 twice with none left over. Why don't you hit pause and try these two? We have the 4th root of x to the 7th over x cubed, and the 5th root of n to the 12th over n squared. Let's see how you did. In this case, x to the 7th over x cubed simplifies to x to the 4th. So the 4th root of x to the 4th is just x to the 1st. So our answer is just x to the 1st. In the second problem, n to the 12th over n squared simplifies to n to the 10th, and the 5th root of that would be n squared. In these two problems, we're dividing two different higher roots. In the first, we have the cube root of negative 108 divided by the cube root of 2. But one of our properties, since these are the same root, so we could rewrite this as the cube root of the numerator over the denominator, or negative 108 over 2. And negative 108 over 2 simplifies down to negative 54. We're taking the cube root, so we've got to think about our perfect cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. So the only numbers that really matter are 1, 8, and 27. It looks like this is the same thing as negative 27 times 2. And since the cube root of negative 27 is negative 3, this simplifies down to negative 3 times the cube root of 2. In the second problem, again, it's the same root, so we can rewrite this as the 4th root of 96x to the 7th over 3x squared. But that fraction will simplify into the 4th root of 32x to the 5th. We're dealing with 4th roots, so we need our perfect fourths. 1 to the 4th is 1, 2 to the 4th is 16, 3 to the 4th is 81, which means the only numbers that matter are 1 and 16. Well, 32 is 16 times 2. And the 4th root of 16 is 2. That'll leave me with the 2 inside. I'm going to think about this in terms of the Orndorff rule. 4 goes into 5 once, so it'll be x to the 1st on the outside with the 1 left over, so it'll be x to the 1st also on the inside. Why don't you hit pause and try these last two problems. Let's see how you did. We have the cube root of negative 192 over the cube root of 3. Well, that's the same thing as the cube root of 192 over 3. But 192 divided by 3 is 64. And 64 is a perfect cube. Oh, it was negative, so it'd be negative 192, negative 64. The cube root of negative 64 is just negative 4. In the second one, this will simplify to be the 4th root of the numerator, 486 m to the 11th, all over 3 m to the 5th. But that'll simplify even more into the 4th root of 162 m to the 6th. Perfect force. Remember, we have 1 to the 4th, 2 to the 4th, 3 to the 4th. 4 to the 4th is 256, so that number's too big. So these are the only 3 numbers that matter. And 162 is 81 times 2. Well, the 4th root of 81 is 3. So that's why the 3 comes out. And 4th root of 2. 4 goes into 6 once. So that's why it's m to the 1st outside with 2 left over. M squared left inside. And there's our final answer. Hope this makes sense. One more short video for this lesson.